Hey guys, welcome to our first lesson for Adult Basic Education Math Level E. This is lesson 1, which is going to be about whole numbers. And the things we're going to be discussing today regarding whole numbers are going to include topics like place value, rounding numbers. We're going to talk about skip counting. We're going to talk about comparing whole numbers, and we're also going to go over what expanded form of a whole number is, okay? So let's go ahead and we will dive right into our first slide. Our first slide is going to be about place value. So when we're talking about place value, I want to give you first an example of a whole number. So let's use something that's in the hundreds. We're going to pick something like 483. And what I want you to notice here is that with every number that you see, we sometimes in math we don't put the decimal point depending on how how we want that information to be displayed. So if it's not important to know what the decimal points are, then we usually leave it off. But really, technically, every number we look at can be expressed as a number that has a decimal point. So I'm going to add the decimal point for this one. And what would come after this decimal point would just be zeros. And that's probably why in the first place we wouldn't even put the decimal, okay? Because these zeros, they don't mean anything. They don't change 483 at all, okay? This is exactly 483. It's not any more or any less, not even partially more or less. So the decimal point is going to be like our dividing line, which tells us where in a number that we should start when we're trying to figure out the place value. So if we're talking about where that's located, I'm going to change colors here. So this bad boy right here, this decimal point is really like our middle point, okay? Here we go. That's our midpoint. And then for any number we look at, the very first spot that we look at is going to be called the ones place. And that's where you're going to be counting numbers by ones. So you're going to be going like 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's the highest that can fit in that place. If you go any higher than 9, the next number would be 10. And that's where we get the name for the next spot, which is going to be the tens place. And we call that the tens place because now we can signify that we're not just counting a small quantity like 1 through 9, we've gone above that. So now we're at 10, 11, 12, 13, 14, and 20, and 30, and 40, and 50, 60, 70, 80, 90. And then once we get past 90, okay, if we're at 99, the next highest number would be 100. And when we hit that 100, we're actually going to be in the territory of the hundreds place. Okay. Now, it can go even further than this because depending on how many of something you're counting, you can go higher than hundreds place. The next highest up would be thousands, okay? And then you have tens of thousands, and then you have hundreds of thousands, and then so on and so on. So while we're talking about place value, I want to go ahead and also discuss something called expanded form. So I'm just going to make a little squiggly here on the slide so that we can kind of separate that. And I want to talk about what expanded form means. All it means is that you can take a whole number and you can break it down into each of its parts. And it's another way to represent how you got to this quantity in the first place. So let's use the same number. Let's use 483, okay? So 483 can be represented by saying that you have 400 of something, and to that 400 of something, you also added 80 of them. And then to that, you also added 3 of them, okay? So this would represent the ones place. This would represent the tens place. And 400 would represent the hundreds place. So that's another way to kind of explain how you would arrive to a quantity like 483. That's what expanded form is, and let me actually just write that out. So And by the way, when you're taking notes for this, if you are taking notes, feel free to, kind of organize this in any way that makes sense to you. Okay. So our next topic we're going to talk about in lesson 1 is going to be comparing whole numbers. And so where I want to start with this is I want to give you an example of, let's say that I'm making dinner and I'm making enough of something so that I have 6 servings, okay? And I live in a house with 5 people, so that'll be basically enough for all of us because, sometimes people go back for seconds or whatever. So I'm making 6 servings of something, and then someone in the house says, well, I'm also bringing so-and-so over for dinner tonight, so that's another person. And now I decide I need to make extra. And then I decide what I'm making is so good, I want to make leftovers so that I have, more servings of it some other day of the week so I can eat leftovers for lunch or something. So that was what I started with, right? So I'm starting with 6 servings. And then I change my mind and decide I'm going to double my recipe, okay? So I'm going to double it, and now I'm going to make 12 servings, all right? So what the heart of this particular, doubled under here. What this lesson really wants you to be able to do is look at 2 different numbers and decide by looking at them which number is larger, okay? That's the gist of what this is. So if we were to take a guess here, we would say that 12 servings would be larger because there are more servings available in this quantity than there would be in 6 servings, okay? Let's give you another example, and we'll take this one up a notch, and we'll do something with like a thousands place, okay? So we're going to go ahead and we'll do a little dividing line here, okay? Here's our lovely dividing line. And let's say that we have a little bit of grass down here on the ground. Take some time painting this in. Okay, here's my lovely grass, all right? And in the grass, we decided that we're going to build some buildings. Okay, so here is the first building, all right? And we can draw some windows in this building, and there you go. It's like a nice giant building. And if I told you that the height of this building was 3,200 feet, okay, that's 3,200 feet, all right. And then there's another building next to it because this is my building, and then you decided that you were jealous and you wanted to build a building also. And here's your building, all right? And yours is just slightly taller than mine, all right? So there's your building. Great job. Here's your awesome building. Here's all your windows in your building. And then you decided that this one, you built yours a little taller, and yours is 4,000 square feet tall, okay? So there's your building. The question here is, which one of these 2 buildings is taller? Which one has a larger quantity of feet in the measurement of the height of the building? Well, the one you built of 4,000 feet is taller, and that is visually represented by the fact that this building is drawn taller than mine. And then let's say, some mom and pop company comes in and they decide they're going to put a building here too, but they can't afford a lot at first. So there's their tiny little building right here. Okay, here's all their windows in their building. Lovely. So their building is only 600 feet tall. Okay. The comparison here is which one of these is the tallest and which one has the least amount of feet and which one would be in the middle. So if you were to draw all the quantities together, we're going to order them from least to greatest. The smallest quantity, or the least, is 600. And then right in the middle of that, we have my building, which was 3,200. And then we have yours, which is 4,000. And that has the greatest quantity. And that's the gist. So what can we tell about these numbers that would lead us to that conclusion? Let's say, for example, we did not have this diagram here. We just had a list of numbers, and how could we figure out which one was larger than the other? Well, the first clue would be how many place values are there. If you look at 600, you have 0 in the ones place, 0 in the tens place, and 6 in the hundreds place. So that only goes up to the hundreds place. And then the other two quantities go up one more notch and they go up to the thousands place. So if there's 4 place values, then these two numbers, 3,200 and 4,000, are going to be larger than 600 by default because they have more place values, okay? And then if you compare these two, each of these is in the thousands. Each one has 4 place values in it. And how would you then determine which one is larger? Go to the highest place value first, okay? The first place value that is the highest is the thousands place, okay? Which one of these is larger, 3 or 4? Well, 4 is larger. So the greatest building has 4,000 feet, and the one right below it has only 3,000 feet, plus 200. But we're only talking about the thousands right now. So if there's 4,000 feet here and 3,000 feet in the other, then by default, the one that has 4,000 will be a larger building. Okay, so the next thing we're going to talk about is rounding numbers. So let's say that you were reading... Okay, so I just realized something. So I want you to do me a favor, and I want you to pause the video. And on this screen that I just put up right now, you're going to see the slide that I was just on when I was talking about comparing the two numbers, okay? Where one is smaller than the other or one is larger than the other. So for some reason, it didn't advance to this when I advanced the slide in my video, but that's fine because you can just go back and listen to all the audio I was saying, and then here's the picture for a comparison. So once you're done, you can pause the video. Once you're done, just come back, and then I'm going to be on the next slide for you, which is about rounding. Okay, so when we're talking about rounding, okay, let's go ahead and draw a number line. So here's a number line. And on the number line, okay, let's put 0 over here on the left. And then I'm going to put 10 over here on the right. So in between 0 and 10, I have what? I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And that is what falls in between here. What do I really care about for rounding? I care about the halfway point. So the halfway point between 0 and 10 is going to be 5. So that's the middle, okay? And that's all we need to know when we're doing rounding, is we need to figure out what's the value right below where I'm at and what's the value right above where I'm at. So let's say I gave you a number and I gave you the number is going to be like 7. Okay, so 7 is like right here on the number line, right? So I'm going to put that number above. We're talking about 7 now. And my question to you is, and let's write this out, is round 7 to the nearest tens place. Or sometimes the problem might just say round 7 to the nearest 10, okay? So if you were to look and see, is 7 closer to 0 or 10, okay? And so for me, looking at the diagram helps the most, and I can clearly see that 7 would round up to 10. It would be closer to 10. But let's say I give you a different example, and I gave you the example of 4. Okay, so I said round 4 to the nearest tens place, or the nearest 10. So let's plot 4. Well, 4 is right under 5, right? Okay. So my question is, if this is the halfway point at 5, is 4 above or below that halfway point? And that'll tell you what it's closer to. Well, 4 is going to be below that, and so we would round 4 down. Okay, so down. 4 would round down to 0. Okay. Now let's take this example one step further, and I'm going to draw another number line here. And on this number line, it's going to be a hundreds number line. So we're going to start at 0, and then at the end of the number line, we're going to have 100. Now, why am I using 0 and 100? Well, my next question is going to be round a number to the nearest hundreds place, okay? And so I either have 0 hundreds, that's going to be over here at the left-hand side of the number line. That's 0 hundreds. I have no hundreds, okay? Or my next quantity up for hundreds, if I'm skip counting, is going to be 100. So think about that. That's 0 hundreds, 100s, 200s, 300s. That's going to allude to actually what we're talking about in the next slide, which is about skip counting. But So here we are, and let's say I gave you the same problem again, except I told you to round 7 to the nearest hundreds place. Okay, so round 7 to the nearest hundreds place. Or sometimes the problem might just say round 7 to the nearest hundreds. Well, the first thing I want to do is I want to identify what's the halfway point. What's halfway between 0 and 100? Well, right here in the middle between 0 and 100 is going to be 50, okay? And then let me plot 7 on my number line. Well, 7 is going to be pretty darn close to 0 at this point, because if I counted these in increments of 1, I would be going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, so on, so on, so on. I'm not going to count the whole thing, but you get the idea. All the way up to 99 and then 100. Well, 7 is pretty low. It's pretty close down here to 0. So my question for you now is, in the first example, 7 rounded up because we were going to the tens place. But if I were to say round 7 to the nearest hundreds place, okay, so that's 1 hundreds. Okay, is this less than the midpoint or is it larger than the midpoint? And it's less than. So this is going to round down. So a particular number does not always round up or down. It really depends on what you're rounding it to. Okay, and where that comes from, if you've ever heard the phrase like rounding something out, it's kind of like making the number more palatable or making it easier to look at. And if I were to round 7 down, well, that's like pretty close to nothing when we're talking about hundreds. So if I were to ask you, let's say I gave an assignment. Okay, I have 100 students and I gave an assignment. Let's give some context to this. And I gave an assignment, okay? And only 7 of my kids submitted something for that assignment by the due date. Do you think I'm going to be going around saying, oh yeah, most of my kids turned in the work? Or is it more likely that I'm going to be saying, well, hardly and none of my kids did the work, okay? And the answer would be hardly none, because 7 is closer to 0 than it is to the maximum quantity, which would be 100. Okay, so we have one more slide, and the next slide is going to be about skip counting. And you already probably do this, and maybe you just didn't know it was called skip counting. But all this means is that you are jumping around the number line by the same quantity every time. So I'm going to give you an example of that so that you have an idea of how you can apply skip counting in like a real situation. So let's say that we are at a party store, right? We're at a party store and we're planning a party, okay? So the number of guests at the party is going to be 82, okay? So I have 82 people coming to this party. And I'm at the store and I'm on the aisle that has the silverware, and what I'm looking at is the cups, right? And let's say the cups come in packs of 25, all right? So if I were to buy no cups at all, no packs of cups at all, so 0 packs, 0 packs, then how many cups did I buy? And the answer would be none. I didn't buy any cups at all because I didn't buy any packs of cups. They come in a quantity of 25. And let's say I decide I'm going to buy 1 pack. Okay? And 1 pack of cups comes with 25 cups inside. Well, is 25 cups going to be enough for 82 guests at a party? And the answer would be no, it's not enough cups, so I need to buy some more. Let's say that I decided to do 2 packs. And when I do 2 packs, that's going to bring me up to 50 cups altogether because each pack I buy has 25. And 50 is still not enough for 82. So let's say I did 3 packs. And that's going to bring me up to what? It's going to bring me up to 75 cups, okay? Still not enough for my party, so I really need to go and do 1 more. Okay, so 4 packs of cups would bring me to 100 cups because there's 25 in each one. And so this is like a really long drawn out example of this because in the store you'd probably just go, oh, 25, 50, 75, 100. Okay, so 75 is not enough and 100 would be enough cups. And you'd make that decision in 2.5 seconds because you can count the quantities pretty quickly in your head, and that's what skip counting enables you to do. It just allows you to skip through. And so you may have done skip counting before where you do like 5, 10, 15, 20 or 10, 20, 30, 40. This is just in a quantity of 25. And that's a real life solid example of when you might use skip counting. So that's actually everything that's in the first lesson for level E for math. So what I'd like you to do next, if you have not done this level already in Essential Ed, I want you to go ahead and log in, and then I want you to do this level 1. There's practice problems, there's like a video lesson that goes along with each thing, and then eventually you pass that level and go on to the next. There's 4 topics altogether for level E, and so if you're comfortable and you want to follow the lessons that are showing up in Essential Ed, you can just keep going. You don't have to wait for me to post something. But there will be 3 more videos from me for each of the additional lessons we have in level E, and then we'll go ahead and move on to the next level up, which is going to be level M, okay? So that's all I have for you today, guys. Thank you so much, and thank you for tuning in. See you later. Bye-bye.